Have you ever looked up at a jet soaring across the sky and wondered, could it just keep going, all the way to space? It's a question that sparks the imagination, the idea of an airplane effortlessly gliding among the stars, but could it really happen? The short answer is no. Airplanes are amazing machines, but they're designed for the skies of Earth, not the vacuum of space. To understand why, we need to delve into the fundamental differences between aircraft and spacecraft. Let's embark on a journey to uncover the science behind flight and explore the exciting possibilities that lie ahead in the quest to conquer the cosmos. Airplanes and spacecraft might seem similar at first glance. Both are vehicles designed to carry us through the air. However, their purposes and the environments they operate in are vastly different, leading to significant differences in their design, functionality, and the technology they employ. But the key difference lies in the environment they're built for. Airplanes are designed to navigate through the Earth's atmosphere, a complex layer of gases that provides the necessary conditions for flight. The Earth's atmosphere is a blanket of gases that surrounds our planet, providing the air that airplanes need to generate lift and stay aloft. This atmosphere is composed of nitrogen, oxygen, and other trace gases, creating a dynamic environment that airplanes are specifically engineered to handle. Spacecraft, on the other hand, are built to operate in the vacuum of space, where there's practically no air at all. This means they must be designed to withstand the harsh conditions of space, including extreme temperatures, radiation, and the absence of atmospheric pressure. This fundamental difference dictates everything from the way these vehicles generate lift to the type of engines they use for propulsion. Airplanes use jet engines or propellers to move through the air, relying on the principles of aerodynamics. Airplanes rely on their wings to generate lift, using the air flowing over and under them to stay aloft. The shape of the wings, known as an airfoil, is crucial in creating the pressure difference that allows the airplane to lift off the ground and remain in the sky. Spacecraft, however, don't need wings. In the vacuum of space, there's no air to create lift, so wings would be useless. Instead, spacecraft are designed with powerful rocket engines that provide the necessary thrust to propel them through space. They use powerful rockets to propel themselves through the vacuum of space. These rockets work on the principle of Newton's third law of motion. For every action, there is an equal and opposite reaction. By expelling gas at high speed in one direction, the spacecraft moves in the opposite direction. In essence, airplanes are built to dance with the air, taking advantage of the atmosphere to glide, turn, and maneuver gracefully. Meanwhile, spacecraft are designed to navigate the emptiness of the cosmos, relying on precise calculations and powerful engines to traverse the vast distances of space. Airplanes need air to fly. It's as simple as that. Their wings are designed to work with the air, not against it. The shape of an airplane wing, with its curved upper surface and flatter underside, is crucial for generating lift. As the plane moves forward, air flows over both the top and bottom of the wing. The curved upper surface forces the air to travel a longer distance, which means it has to move faster. This faster-moving air creates an area of lower pressure above the wing. The higher pressure below the wing then pushes it upwards, creating lift. So air is not just something that surrounds an airplane, it's an essential ingredient in the recipe for flight. Imagine an airplane trying to fly higher and higher, eventually reaching the edge of the Earth's atmosphere. As the air gets thinner, the wings would have less and less air to push against. Without enough air, the wings wouldn't be able to generate enough lift to support the weight of the airplane. It would be like trying to swim in a pool with no water. The airplane would stall and begin to fall back to Earth, no matter how fast it tried to go. Section 5. A rocky relationship, air resistance and speed. As an object moves through the air, it encounters resistance, a force that opposes its motion. This resistance is due to the collision of air molecules with the surface of the object, creating a drag force that acts in the opposite direction of the object's movement. This is called air resistance or drag. Drag is a crucial factor in aerodynamics and plays a significant role in determining how efficiently an object can move through the air. The faster an object moves, the more air resistance it encounters. This is because the object is colliding with more air molecules per second, increasing the overall drag force. Airplanes are designed to minimize drag, but it's still a factor, especially at high speeds. Engineers use streamlined shapes and smooth surfaces to reduce the impact of air resistance, allowing the aircraft to move more efficiently. Now imagine an airplane trying to fly into space. As it ascends, it faces a unique challenge. As it climbs higher and higher, the air gets thinner, which means less air resistance. Sounds good, right? Well, not really. While reduced air resistance might seem beneficial, it introduces new problems. While less air resistance might seem like a good thing, it also means less air for the engines to breathe. Jet engines rely on a steady intake of air to function properly. Jet engines need air to burn fuel and produce thrust. Without sufficient air, the combustion process is compromised, leading to a significant drop in engine performance. Without enough air, the engines would sputter and die, leaving the airplane stranded. This delicate balance between air resistance and engine performance is a critical aspect of aviation engineering, ensuring that aircraft can operate safely and efficiently at various altitudes. Section 6. Burning up. The heat is on in space. Let's say, for argument's sake, that we somehow managed to design an airplane that could reach the edge of space. Even if it could overcome the challenges of lift and engine operation, it would still face another formidable obstacle: heat. When an object enters the Earth's atmosphere from space, it experiences intense heat due to friction with the air. This is why spacecraft need special heat shields to protect them during re-entry. Airplanes, on the other hand, aren't designed to withstand such extreme temperatures. So even if our hypothetical spaceplane could reach the edge of space, it would likely burn up on the way back down. Section 7. Spacecraft, built for the final frontier. Unlike airplanes, which are designed for the comfort and efficiency of flight within the Earth's atmosphere, spacecraft are specialized vehicles built to endure the harsh conditions of space. Airplanes rely on the presence of air to generate lift and thrust, making them perfect for terrestrial travel. However, the vacuum of space presents a completely different set of challenges that require innovative engineering solutions. Spacecraft are built to withstand extreme temperatures, navigate the vacuum of space, and carry their own oxygen supply, making them suitable for the challenges of space travel. The temperature in space can swing from scorching heat to freezing cold, and spacecraft must be equipped with thermal control systems to manage these extremes. Additionally, the lack of atmosphere means that spacecraft must be airtight and carry all the necessary life support systems for astronauts. Their powerful rocket engines, designed to function in the absence of air, propel them through the cosmos. These engines use chemical reactions to produce thrust, allowing spacecraft to maneuver in the vacuum of space. Unlike jet engines, which require air to operate, rocket engines carry both fuel and an oxidizer, enabling them to function in the void of space. Additionally, they are equipped with robust heat shields to protect them from the fiery re-entry into the Earth's atmosphere. When a spacecraft re-enters the atmosphere, it encounters intense friction that generates extreme heat. Heat shields are designed to absorb and dissipate this heat, ensuring the safety of the spacecraft and its occupants. These features make spacecraft uniquely capable of venturing into the vast expanse beyond our planet. They are designed to travel millions of miles, exploring distant planets, moons, and even asteroids. The ability to operate autonomously for extended periods is crucial for deep space missions, where communication delays with Earth can be significant. Spacecraft are a testament to human ingenuity, pushing the boundaries of what's possible and allowing us to explore the cosmos like never before. They represent the pinnacle of technological achievement, combining advanced materials, cutting-edge electronics, and innovative design. As we continue to develop new spacecraft, we unlock new possibilities for scientific discovery, space tourism, and even the potential for human colonization of other worlds. Section 8. The future of flight. Spaceplanes on the horizon? While traditional airplanes can't fly into space, that doesn't mean we've given up on the dream of seamless travel between Earth and the stars. Engineers and scientists are hard at work developing new technologies and vehicles that could blur the lines between airplanes and spacecraft. Imagine a vehicle that could take off from a runway, soar into orbit, and then glide back down to Earth for a smooth landing. These hybrid vehicles, often called spaceplanes, could revolutionize space travel, making it more accessible and affordable. The dream of reaching for the stars is very much alive. And who knows, maybe one day, we'll be boarding space planes as casually as we board airplanes today. Section 9, Conclusion, Reaching for the Stars. So, while we can't simply hop on a plane and jet off to space, the pursuit of that dream has driven incredible innovations in aerospace engineering. From the sleek design of supersonic jets to the development of reusable spacecraft, we're constantly pushing the boundaries of what's possible. The laws of physics might dictate that airplanes stick to the skies, but they also fuel our imagination and inspire us to reach for the stars. As we continue to explore the cosmos and unlock its secrets, one thing's for sure: the future of space travel is bound to be as exciting as it is groundbreaking.